In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a product. It says evaluate the following limit using L'Hopital's rule. It says the limit as x approaches 0 from the right is of negative 5x natural log 7x cubed. And they say from the right because natural log is not defined for anything to the left of 0. So if we plug in 0 here, we're going to end up with 0 times the limit as you approach 0 from the right for this natural log. You end up with this 0 times the 0 times infinity piece here. So we're going to say that, and actually it's negative infinity, because if you take the limit, let's do something real quick. We'll do natural log of like 0.1. Yeah, you're going to be approaching negative infinity. So this is 0 times negative infinity. So this is indeterminate. What we want to do is we want to apply L'Hopital's rule, but to do that we have to have a fraction. So we're going to rewrite this using a little algebra technique to make it so that we can apply L'Hopital's rule. So negative 5x is actually the same as 1 over negative 5x. So I can write this in place of what's written here with negative 5x. So that's what I'm going to do for this problem. I'm going to write natural log of 7x cubed divided by 1 over negative 5x. So what I can do now is I can apply L'Hopital's rule. So I can take the derivative of the numerator and the derivative of the denominator. When I take the derivative of the numerator, I end up with limit as x approaches 0 from the right. I will have a derivative of natural log. We're going to get 1 over 7x cubed times the derivative of the inside, which was 7x cubed. Chain rule. And then when I do the derivative here, I bring the x to the numerator essentially. So I'm going to have negative 1/5 x to the negative 1. When I take that derivative, negative 1 comes to the front, I get 1/5 x to the negative 2. So we're going to have this be 1 over 5x squared. Now I'm going to take the reciprocal of this denominator and multiply it to the top. At the same time, I'm going to take the derivative of 7x cubed. So it's 21x squared. So this will be 21x squared in the numerator over 7x cubed. And then I'm going to be multiplying it times the reciprocal of this fraction, which is 5x squared over 1. When I start multiplying, I can cancel here, so 21 over 7 will just leave you a 1 and a 3 here. So I end up with 15 x to the second times x to the 7 as x to the 4th over x cubed. X to the 4th over x cubed is 15x. I should have written limits on each of these, so I'm going to write limit as x approaches 0 from the right of 15x. Plug 0 in there and I end up with 0 for a limit. So now I can say that the limit as x approaches 0 from the right of my original function, which my original function is written right here, this whole piece, is 0. And that's an application of L'Hopital's rule.